Hey listeners, it's me, your host, Alexis Pedrick. We're taking a slight detour from your regularly scheduled programming to talk about cars and their effect on the environment. In this episode, our producer, Rigoberto Hernandez, sat down with Paul Donald to talk about his book, Traffication: How Cars Destroy Nature and What We Can Do About It. In this interview, they talk about the profound effects of cars on wildlife, including roadkill, habitat fragmentation, noise pollution, and more, and offer some practical solutions to mitigate these impacts.
For those of us who are unfamiliar with the term, can you tell us what is road ecology?
Road ecology, it's a fairly recent branch of science. It was given a name in 1999. In fact, it was kind of the phrase was coined, and it's essentially a branch of ecology stroke conservation science that deals with the impacts of roads on the environment. And it's a recently recognised sort of branch of science because I still think, and it's still the case today, that a lot of people, including a lot of ecologists, don't realise how profound and serious the impact of motor vehicles actually is.
The title of your book is called Traffication. Could you tell us what does that mean, and can you kind of break down what are its components?
I found it very odd when I was trying to think of a word to describe this phenomenon, that there is no word in the English language that describes the growth in the number of cars, the pervasiveness of cars in our lives, the number of miles that they drive, the polluting power and so forth. It's really weird. It's one of the biggest societal and environmental changes of the last century, and we don't have a word for it. And I couldn't write the book without it, so I had to make up a word to describe this thing that we all see on a daily basis, but have no word for. So traffication was the best I could contrive. But I think if you break down traffication into its components, it's more than simply the number of cars on the road. Of course, that's increased massively. But I identified three sort of components of traffication, if you like, the three elements, all of which have sort of slightly different impacts on the environment. So the first is, it is the growth in car numbers, and particularly the growth in the distances that they travel. So my sort of back of the envelope calculations, because there isn't a global figure, is that the world's motor vehicles drive something like 15 trillion miles over the planet's surface every year. 15 trillion miles. That's 2.5 light years. And it is an astonishing distance. If you drew a line that represented 15 trillion miles, you wouldn't be able to see the planet Earth on it. I mean, it would be microscopic. And it's a kind of an interstellar distance. Somehow these 15 trillion miles of travel are compacted onto the dry third of a tiny, tiny planet. That's the first component of traffication. It's the distances that we drive, which is a product of the number of vehicles and the distances that each of those vehicles drives. The second component of traffication, which is really important for wildlife, is speed. The average speed of vehicles has increased since cars began. Obviously, nobody would think otherwise, but it's continued to increase. And road surfaces have become better. So vehicles travel, when they're not in congestion now, faster than they ever used to. And one of the take-home messages from the book is that reducing speed is the biggest thing that we can do to reduce the environmental impacts of cars. Pretty much all the negative impacts of cars on our health, on wildlife, on the environment increase exponentially with speed, the key word there being exponentially. A car travelling at 30 miles an hour produces more than twice as much noise as a car travelling at 20 miles an hour. So that's the kind of second dimension of traffication, is that the speed of cars has increased. And then the third dimension of traffication, if you like, is that cars are more pervasive in that the road system has expanded. There are fewer and fewer areas left on the planet's surface that aren't impacted by cars. So this idea of pervasiveness, the spread of roads, sort of spatial spread of roads into our lives, into the countryside, is the third element. So you have those three elements of what I call traffication, which is, number of vehicles, the speed of those vehicles, and the prevalence of those vehicles in the environment. And each of those has slightly different, or very different in some cases, ecological impacts. So what I do is I kind of define this issue called traffication, then break it down into its sort of little component parts and analyse each of those separately.
Yeah, it's interesting because of those three components, they all seem to be increasing over time. And they increase in very subtle ways to the point where we might not even notice them.
Yeah, I think all three of those things, all three components of traffication have increased hugely. To give you an example, the traffic levels in 2020 when we had the COVID lockdown, when everyone was saying, God, isn't it quiet? It's amazing how few cars there are on the road and so on. The traffic levels in Britain during that year were actually higher than they were in the 1990s. So you don't have to go back very far to find a world that we would recognise as being noticeably different in terms of the number of cars. Speeds have increased. Now, of course, speed limits haven't increased terribly much, but as the capacity for vehicles to go faster increases, so people are tempted to exceed the limits. People can accelerate faster. They reach their chosen travelling speeds more quickly. So even though the maximum speed limit on any road in the UK is 70 miles an hour, the average top speed of the average car on British roads is well over 100 miles an hour. It's not often that cars are driven to their maximum speed, but this increase in speed allows people to reach their chosen speeds more rapidly and tempts them to exceed them.
And that ties me into this point about why there's no term for the impact that a car has in our environment. Could you guess why that might be? And my sense is that it's because it's become so pervasive and that it's part of the environment itself now.
I think it's probably because it's happened so slowly. So each of those components has increased at about 1% per year, and we don't notice 1% per year changes. You only have to go back to the 1990s before you reach the levels of travel that we had during the COVID lockdown. So it's partly because we haven't noticed it because it's been a very slow process. But also, I think, coming back to this word traffication, I also think the reason we haven't noticed it is because we haven't got a word for it. So if you don't have a word for a problem, how can you conceptualize it? How can you even start to talk about it, let alone recognize it as a problem, if you don't have a word for it? And I hope that by giving it a name, people will start to conceptualize it a little bit more for what it is, as a sort of, I think an environmental problem to rank alongside climate change, the invasive species, the intensification of agriculture.
You say that roadkill is not a random event. Could you tell us a little bit more about that?
Yeah, so we tend to see these animals splattered on the roads and think, well, yeah, it's just bad luck, poor animal sort of thing. I think there are two aspects about roadkill. Firstly, it is a predictable event. We can predict next week's roadkill in a way that we can't predict next week's lottery numbers. It's a combination of mathematical, very difficult to measure, but mathematically quantifiable probabilities. So it's the probability that an animal crosses a road multiplied by the probability that it's going to be killed if it does cross that road. And we can sort of predict some of those probabilities a little bit. So we can kind of say, well, this badger stands a much bigger chance of being run over next week than that badger does because of its road crossing behaviour and the kinds of roads it crosses, when it crosses them, how it crosses them, and so forth. So it's not a random event, but it is a very conspicuous event. So if you say to people, oh, the environmental impacts of roadkill, this is exactly what I had when I was writing the book. I said, I'm writing a book about the environmental impacts of roadkill. And people were saying, well, how can you write a whole book about a few dead badgers and hedgehogs? But I actually think that roadkill isn't the biggest problem. I think it's far from being the biggest problem. It's the most visible part of the problem, and it might possibly explain why we don't see traffication, as I call it, as being a big environmental problem, because these dead animals have been lying on the roads all our lives. So in a sense, they've desensitized us to the issue, sort of allowing it to hide in plain sight.
You write in your book that people don't get riled up about roadkill because to some degree it's not intentional. They didn't set out to kill this poor animal with their car, but it's kind of contradictory because the first law of roadkill is that it's not an accident or a random chance. So that's the contradiction I see.
That's exactly right. And I think that's why this insight that roadkill isn't a random event is such an important one, because it shows that we can do something about it. If it was a completely haphazard random event beyond our control, then you're right, there would be nothing we could do about it, but it isn't. And knowing what we know about roadkill, there's a lot of things we can do. We know that speed plays a big part. I'm going to keep coming back to the issue of speed because speed is the big problem. So I think roadkill is, firstly, it's not the biggest problem that cars pose to wildlife. And secondly, I think it's, of all the problems that cars pose to wildlife, it's one of the more tractable ones because there's a lot of things we can do about it.
Let's talk about some of the other ways that the car affects the environment. And I actually want to start with the way that the highways, the built environment, plays a role into this.
The reason I think that roadkill isn't a problem is that animals that are killed in large numbers on roads share a common characteristic. They live in large numbers around roads. And if they can tolerate the presence of roads, and if they're happy to cross them, then maybe they're not the ones that are being worst impacted. There's a whole other group of animals that never cross roads at all, and they, I think, are the ones that are more impacted. But what's happening is that roads are cookie-cutting the countryside into ever smaller slices, into little habitat islands surrounded by asphalt walls, if you like. And this, we know from studies of species on islands, can have really profound effects. If you think of a road island, so a patch of land that's surrounded on all sides by roads, there'll be a lot of animals in that little patch of land that are now effectively cut off from other populations nearby. So what we've done is we've fragmented the landscape more quickly and to a finer degree than anything else in our history. We've cut the landscape into hundreds and hundreds and hundreds of little tarmac-walled prisons for these species. So these are species that you don't see on lists of roadkill, but I suspect that particularly given climate change and this, the fact that species need to shift their ranges to track changing climate envelopes, they're now trapped inside these little tarmac wall prisons.
If you can imagine all these highways intersecting with each other, or even like roads intersecting with each other, you're left with a bunch of little islands that the animals choose not to cross, and therefore their environment is just limited to that island now, which leaves them susceptible to, is it crazy to say extinction or
Absolutely extinction. I mean, this whole concept dates back to the theory of island biogeography, and a book published in the 1960s showed that the smaller an island, obviously the fewer numbers of a particular species it can hold, and the greater chances that that population will go extinct. Because if you've only got a small population of animals stuck in an island and a tornado comes on, or a hurricane, or whatever, or you get a drought followed by a tsunami, whatever it happens to be, that population stands a bigger chance of getting wiped out than a much bigger population spread over a much bigger area. So yes, I think we will start to see extinctions happening inside traffic islands.
Could you give us a sense of what animals we're talking about here, the ones that don't cross the road that are stuck in these islands now?
It's quite interesting. There's a whole science or sort of branch, if you like, of road ecology, which looks at how animals cross roads, or whether they cross roads at all. And you can sort of split them into the animals that never cross roads at all, and then those that cross them in different ways. Either they sort of blunder across without even knowing the road's there, or they stop and pause, or they speed up, or whatever. But the road avoiders, the ones that don't cross at all, include a very large number of mammals, particularly smaller mammals, a lot of invertebrates, mollusks, insects, and so forth, are very averse to crossing roads. But it all depends on the nature of the road as well. So you might find that a species that will happily cross a very quiet, narrow road won't cross a busier road. So it's partly a function of the road itself that determines how trapped these animals are in their little islands. I think all snails avoid roads, not so much for the traffic. I don't think that snails can necessarily detect an oncoming car as a threat. I suspect it's something like, roads are made out of oil which gives off poison. So, I mean, if you're a snail, a road might smell terrible, or, it's unfamiliarity, or it's, the differential of heat, it's dry, no cover from predators and so forth. So there's a lot of animals that won't cross roads even if there are no cars on those roads. It's simply the road surface itself is enough of a deterrent to stop them from crossing. And of course, with snails, we all know that mollusks don't like salt. And of course, there's a lot of salt put on roads. So I say in the book that roads can divide snail populations as effectively as would a river of salt. And in a sense, as far as snails are concerned, some of them are rivers of salt because we put so much salt on the roads every winter.
Can you tell me about how noise changes animal behavior?
When we understand the problem better, I think noise will turn out to be the most important impact of traffication on wildlife, at least for birds and mammals. So birds in particular, many species are acutely sensitive to traffic noise and simply move away from areas where there is heavy traffic noise, or even not very heavy traffic noise. Even a minor road carrying just a few tens of vehicles every hour can drive down populations of birds in the surrounding area for a mile or even 2 miles. Now, when you look at a country like the UK, everywhere is within a mile or 2 miles of a road. So the populations of many species have undoubtedly been driven down over very wide areas by traffic noise. And the problem manifests itself in different ways. So firstly, it comes as a surprise to many people to know that birds don't have very good hearing. Actually, our hearing is much better than birds' hearing. We can hear birds from about twice as far away as birds can hear from each other. So they're struggling to hear other birds already. So there's this breakdown in sort of communication between animals, which is a vitally important part of life. But then there's also, just like in ourselves, roads cause elevated stress levels So blood stress hormone levels are known to be higher in animals living near roads than those not living near roads, as they are exactly with people. I mean, noise pollution is a massive killer of people. Hundreds of thousands of people every year die of road traffic noise pollution. A lot of people don't know that. And then the third element would be that, and it's quite interesting, what happens is that the birds that don't move away from roads try to adapt to the presence of roads by changing their voice. They lift their voices to try and kind of shout over the surrounding noise pollution. But it doesn't work very well, because when they shout their songs out, their songs become simpler. They can't sing songs that are both loud and complex. And we know that complexity is one of the elements of a song that females find attractive and rival males find intimidating. So the effectiveness of their song has been wiped out as well. And the same is true with singing frogs. So many frogs sing to advertise a male, and we found that traffic noise impacts them just as much as it does other species. There's a nice example of a particular species of tree frog, which has a lovely yellow-orange vocal sac, that kind of big bubble beneath its mouth that blows out. And stress from road traffic noise causes that bubble to lose its colour. But the colour is lost more in more dominant males, those with the richer colours to start with. So the females then have struggled to work out which are the better males. They can't hear the song, and the visual element of the display has been lost as well. So we're only just starting to realise the complexity of some of these impacts that road traffic has on wildlife.
Does that have implications for how they mate and their longevity?
Yeah, certainly there's a lot of evidence to suggest that birds living near roads have very much lower breeding success than those living further away. And as I said, the response of many birds is simply to move out of those areas. They become abandoned, no matter how good the habitat. It might be a nature reserve, it might be beautifully managed, lovely habitat. If it's near a road, it just won't be used. It will be abandoned.
Can you tell us about the urban sparrows and how that might be an example of what we just described?
Yeah, there's a lovely study from San Francisco looking at white-crowned sparrows singing, and the researchers there, research led by Elizabeth Derryberry, was for many years have been looking at the song patterns of urban white-crowned sparrows in San Francisco and their rural cousins just over the bridge in Marin County. And they found that the songs of the urban sparrows were very, very different. I mean, not just a subtle difference, a difference that if you heard a tape recording of the two, you would know instantly which was an urban one and which was a rural one. So the urban ones are much higher pitched. They're trying to sort of climb above the traffic noise pollution. But then when lockdown came in 2020, what the researchers found was that the songs in the urban sparrows immediately reverted to the natural song, the song of the urban birds, immediately went back to that. So it's a really interesting example of how rapidly birds can adapt and sort of change their behaviour according to the ambient road noise levels.
Yeah, so it also shows us that they don't like being loud.
Exactly. We tend to think of song as sort of incidental, a nice sort of thing, but for birds it's a vitally important part of existence. It's kind of a do or die part of their lifestyles, and anything that causes them to change that can only be a bad thing. And what the researchers found was, even though that the songs of the urban sparrows dropped both in pitch and in volume, they could still be heard further away in the newly quieted air of the lockdown than they had been able to be heard during pre-lockdown years.
How did the lockdowns change the use of road and pollution and noise and light that is emitted? What did we observe when COVID happened?
Huge changes. In a sense, road ecologists are hampered because they don't have the kind of clout to say, okay, we want to do a study of motorways, so we're going to close this motorway for 10 years and record what happens. No one's going to allow them to do that. They don't have enough sort of political clout to do that. But the COVID lockdown was a kind of nice, natural, sort of semi-experimental process where studies like the one of the sparrows in San Francisco could sort of see, well, what happens now the traffic noise has stopped? And all sorts of things happened. We know that many species of birds and mammals that normally avoid roads moved closer to roads during the brief period of lockdown. We know that their behaviour changed. We know that birds and mammals that are normally sort of shunted into a reclusive nocturnal existence became diurnal again, started using roadways as ways through the environment. Their health improved, roadkill rates dropped. I mean, massive changes, really massive changes.
Did it confirm how detrimental the car is to the environment for these animals?
It was a nice demonstration that all the previous research that suggested that road traffic is really bad for the environment is right. It was a kind of confirmation on a scale that researchers would never be able to recreate in the real world.
How does light impact animals?
Light's actually, when you think about it, an extraordinary thing. This pattern of daylight and darkness. So there's been life on this planet for billions of years. And over those billions of years, almost everything has changed. The acidity of the sea, the temperature, where the continents are, almost everything has changed except the period of light and dark, which has not changed since the Earth began, more or less. This pattern of light and dark is essentially the metronome that sets the rhythm of life. And of course, if we start polluting darkness with thousands and thousands of miles of road lights, and possibly more worrying still is the horizontally projected light of car headlights, then we're fundamentally altering one of the most basic kind of mechanisms that animals use in determining their lifestyles. So if you drive through woods on a dark night with your full beam on, you're essentially turning night into an overcast day. And this is having profound effects. And I suspect that when we know more about it, I mean, this is a study that's really in its infancy. I suspect when we know more about it, we might find that light pollution is one of the most serious impacts that we're having with cars.
Let's move on to another unseen effect that the car has in the environment. And this one I didn't even realize myself. It's tire particles.
If you say to somebody, oh, car pollution, air pollution from cars, they will form a mental image of a tailpipe with black smoke coming out of it. And that would have been true 20 or 30 years ago. Majority of the particulate emissions did come through the engine, through combustion, byproducts of combustion. But engines have improved so much now. We have all this post-combustion filtering and so forth that actually the amount of particulate pollution being put out through the tailpipe is a fraction of what it used to be. But tyre particles are now probably the most dominant form of particulate pollution from traffic. So these are little tiny, tiny bits of microplastics that get worn off tyres. If you're driving along a road at a very modest speed in a car with correctly inflated tyres, those tyres are producing 1.5 trillion microparticles of plastic every kilometre that you drive. So tyre particulate pollution now greatly exceeds exhaust particulate pollution. And we're just starting to realise what kind of impacts this might have. And this really is a science in its absolute infancy. But there was a very famous case regarding a fish called the coho salmon. And people living around the Puget Sound, Seattle and surrounding cities noticed that every year salmon returning from the sea to freshwater streams were dying in huge numbers. And researchers noticed that these mass die-offs of salmon were happening particularly after periods of rainfall, and they speculated that pollutants might be being washed out of the urban environment into these streams, and it might be some of these pollutants that are killing the salmon. So they spent years and years filtering all these different chemicals, and they eventually found that when they put road tyre particles into water containing coho salmon, the salmon exhibited the same symptoms. They started gasping for air, dying, and so forth. So they recognised tyre particulates as the problem. Then they had to wade through all the hundreds and hundreds of different chemicals that people put in tyres that tyre manufacturers use. And they eventually found one called 6-ppdq, which was killing salmon. And that was the kind of toxic agent. And 6-ppdq is formed by the reaction of a chemical 6-ppd, which is in practically all the world's tyres. And it turns out that 6-ppdq, which nobody knew even existed before this came along, is acutely toxic to coho salmon. Bizarrely, not to some other species of salmon, but to coho salmon and a few other, there's some trout, for example, it kills them very quickly. And then the problem kind of gets worse in a way because the researchers thought, wonder what other chemicals are being produced by 6-ppdq and ozone, and they found no fewer than 38 of them. And we know nothing at all about what species they may be toxic to, or even how toxic they are to us. And not just tyres either, so brake lining, dust from brake lining as well. And this is a sense why, again, it comes back to the issue of speed, because if you drive fast, you accelerate fast and you brake fast, you produce hugely more tyre wear and brake wear particles than if you drive at a steady speed. So again, even things like this tyre wear particulate all comes back to speed in the end.
There's a lot of talk about electric vehicles replacing the combustion engine, and they're touting all these benefits that are associated with electric vehicles. But in some ways, they kind of have the same components that a car does, which is a tire and brakes.
Yeah, and being heavier, they actually produce more tyre wear particles and more brake wear particles. So it is true. I mean, people are as you say, people are saying, oh, well, the problem with the cars ending now, we've got electric vehicles, will all be electric soon, all the problems will go away. Of course they won't. And in fact, I think electric vehicles won't make any difference. If anything, they could make things a lot worse. As I say, they produce more non-exhaust particulate emissions than standard cars do, several times more. Most worryingly of all, I think, is that they will encourage people to drive even more than they do now. There's some preliminary results coming out of places like Australia that suggest that when people make the switch from petrol-fueled cars, gasoline-fueled cars, to batteries, they drive about 600 kilometres more per year than they did previously. Now, if everyone does that, that's hundreds of billions of more vehicle miles on the roads every year. And people say, well, you're worried about traffic noise. Well, electric cars are silent. Then, that problem will go away. It won't, because most of the noise that comes from cars now is friction noise from the road and aerodynamic noise. And above about 30 miles an hour, electric cars make the same noise as combustion cars.
Yeah, you're basically just transporting. It brings with it all the same problems that it has. It's not a magic bullet. But it's been sold as one, which is the worrisome part.
It's on the one hand, it's been sold as one. And on the other hand, all these electric vehicle manufacturers are making cars that are so much vastly overpowered and oversized than they need to be. I mean, what is the point of making an electric SUV? What's the logic there? I mean, if the logic of electric cars is to reduce the environmental impacts, you make cars smaller and lighter. That's how you reduce, and slower. That's how you reduce the environmental impacts of cars.
I want to hear more examples of animals, and I think one that comes to mind is the cliff swallow, the relationship to the road and what that tells us about road ecology.
The earliest road ecologists were a couple called the Stoners, Dayton and Lillian Stoner. And in 1924, they made this road trip across Iowa, and a perfectly ordinary trip made by millions of people. But what made this journey unique was that they counted the roadkill that they saw along the way, and they published the results. It was 1925, they published an article, and it was the first scientific article ever published on the environmental impacts of the car. So they were the kind of original road ecologists, if you like. And it was quite interesting looking at the list of species that they recorded. And one of them, the species that they recorded a lot, was pet cats, domestic cats. They were recording something like one dead pet cat every 60 miles in 1920s sparsely populated rural Iowa. Now, if we were to see that rate of cat roadkill today, we would be astonished, we would be horrified. I mean, it's very rare that you would see that. You imagine going on a 300-mile journey and seeing 5 or 6 dead cats. You would be astonished to see that, even though there's much more traffic around now and many more people and many more pet cats. So clearly something's happened here. Roadkill rates of cats have fallen. And this could happen in a number of different ways. It could be because cats have become kind of sensitized to roads. They have become more aware of them as a danger. And that could happen in many different ways. Adaptation to animals to roads, the evolutionary adaptation of animals to roads is a really interesting one. So if you imagine that cats back in the 1920s contained a mix of cats that were completely road savvy and didn't like noise of any sort and wouldn't go near roads, and cats that were kind of gung-ho and decided they would go where they want. The gung-ho ones would get killed off, leaving the more road-savvy ones to breed, and it's possible that, road savviness is passed on to generations. So over time, you would expect to see, cats perhaps becoming more and more the dangers posed by roads through this extra mortality of the kind of the ones that don't see the danger, if you see what I mean. But whether that happens in wild animals or not is unclear. But there's one really interesting study that suggests that it does. So this was a long-term study of cliff swallows in Nebraska by a couple of researchers called Brown. And they found that cliff swallows, if you think of the name, cliffs, they like nesting on cliffs and rocky faces, and all these new roads that were being put in, all the road bridges, were wonderful for them. They thought, great, there's loads more habitat here now. The majority of cliff swallows in America now nest on or near roads because of this fantastic nesting site that they like. But of course that means that they have to live with cars in the breeding season. When they're nesting, they're living feet away from cars. So you'd imagine that the roadkill rates would be very high. And in the early years of their studies, the Browns were finding lots and lots of dead swallows on the roads. And luckily, they kept them. And they kind of preserved the specimens and so forth. And what they found was that over the course of their study, it was a long-term study, it was a decade or more, they found that actually, even though the number of swallows was going up and the number of cars was going up, the number of roadkill swallows they found went right down. And they were very puzzled by this. Why on earth you'd expect there to be more roadkill swallows? And what they did was they measured the wing length of the swallows that were killed on the roads and compared it to the wing length in wild birds that hadn't been killed. And they found that what was happening was that it was the longer winged birds that were being killed. And this is probably because short rounded wings in bird confer manoeuvrability. Long thin wings give you speed, short rounded wings give you manoeuvrability. So hawks, for example, have short rounded wings because they hunt by agility, and falcons have long thin wings because they hunt by speed. And what they suggested was that the longer winged birds were less manoeuvrable and therefore more likely to be hit by cars. And over time, because the long-winged birds weren't passing on their long-winged genes to their offspring, over time the entire population became short-winged and roadkill rates fell right down. So this suggests that road traffic is a really strong evolutionary force. It's a really strong driver of natural selection. And who knows what other examples there are out there. That's the only one I'm aware of. I don't think there are any others. And surely there must be loads of really interesting stories to look at in this area, I think.
I want to talk about the effect that cars have on bees. How does that impact our crops, and how does that impact population of bees?
Bees are quite interesting. As you say, they're important pollinators. They're also a group of species that are very unwilling to cross roads. So they're kind of species that are going to be hemmed into little traffic islands. So they're going to suffer all those impacts as well. But there's another way that they suffer as well, because they're covered in hairs. They're covered in hairs largely because they carry pollen back to the hive. And what happens is that these hairs, when the bees are flying on, develop a little electrostatic charge. And that attracts particulate pollution from vehicles onto the bees. So they become these little flying blobs of poison. And this poison is then taken back to the hive and it enters the honey that we eat on our toast. So they're suffering in many different ways. And of course, they're vitally important creatures, bees, because they're fundamental to pollination services. And that includes the pollination of our crops.
Could you talk about the tradition of these death lists with the stoners and how that happens with today with people tracking down this stuff and why it's important to do it?
Yeah, I mean, roadkill is far and away the most obvious sort of impact of cars on wildlife. We see it every time we go out, more or less. And since the days of Dayton and Lillian Stoner back in the 1920s, they were the first people to actually sort of record roadkill and publish a list. This science of roadkill research has really grown. And there was this great sort of plethora of studies published in the 20s, 30s and 40s called dead listing. It was a little sort of fashion that researchers had. If you think about it, counting the dead animals that you see as you drive along a road and then sort of identifying them and producing a table and sending it off to a scientific journal, it's quite a nice way, easy way of collecting data. And there were hundreds of these studies published. And in a sense, there still are. There's still a huge amount of work being done on roadkill. But it's kind of matured over the years from a kind of, here's a list of the dead animals I saw, into a science that tries to not simply document roadkill, but to try and understand and predict it as well. And road ecologists have realised that there's no better group of people to collect data for them than drivers. And so there's a whole load of new, very exciting schemes opening up around the world, which use drivers as scientists. So they get the drivers to record the roadkill for them. Obviously, you can cover a much bigger area, millions of miles, by getting drivers to record the data for you.
Why is it important to do that? What can we glean from that?
So smaller animals might just be obliterated when they're hit by a car. They might be mortally injured and walk away. So it's actually incredibly difficult to work out actually what the scale of the problem is. And one of the best ways we can do it is by collecting more data on roadkill rates. If you work out what number of badgers or foxes or birds or whatever it is are being killed every year and plot it out on a graph over time, you can actually get an idea of what's happening to the population of that animal, whether it's going up or down. Now, if it's going down, it might be because of the roadkill, or it might simply be that roadkill is recording a decline that's happening for other causes.
You wrote about how we live in the Anthropocene, the age of humans being defined by cars. Could you talk a little bit more about that and how that wasn't always going to be the case?
This whole idea of the Anthropocene is still, I mean, a lot of sort of geologists and biologists don't sort of really buy into it. They think it's a bit of a gimmick. But the idea is that geological era are defined by changes in the geology of the Earth. And the suggestion is that we have wrought such changes on the planet that our impact will be visible in the geological record, in the far future in the geological record. And I kind of speculate in the book, half jokingly, that when people excavate down through the various layers, if we survive for another million years and we still have archaeologists and paleontologists, if they dig down to the layers that we're living in now, they may find this sort of thin layer of tarmac. They'll certainly be quite puzzled by the amount of roads that we have. We think of the car as a kind of fairly modern thing. I mean, it goes back about 150 years, about the same as the bicycle. They're invented about the same time, for those car owners who think that bicycles are primitive somehow. It's not inevitable. I sort of feel that we've been dragged here willingly, that the car is definitely not the ideal solution to our transport needs. It has health impacts that have now become impossible to ignore. I say in the book, I think that in its ability to blind us to its health impacts long after they became scientifically undeniable, that the car's the natural successor to the cigarette. Millions of people lose their lives every year as a result of it. It perpetuates all sorts of social inequalities and so forth. I mean, it really is not the ideal transport methods, and yet here we are. We are where we are, and we've sort of been dragged here more or less willingly. Having a car is nice if you can afford it and you've got one. And the whole industry is driven by immensely powerful petrochemical and manufacturing interests who largely have governments in their pockets. Think of the tax revenue that governments get from selling petrol. People are now wondering, how are the government going to make up for this when we all go electric? They're going to have to start taxing electricity, taxing other things to make up for the difference. So we seem to have sort of gone down this one-way street towards traffication when plenty of options were available to us. But I think things are changing. I think that particularly in cities, people are thinking, we don't want all these cars everywhere. There's better ways of using this space. We don't need to suffer the noise, the pollution that these vehicles are producing. And a lot of cities are embracing this now. I mean, some very forward-thinking countries like the Netherlands, for example, they have many city centres now completely car-free, and they have wonderful bicycle lanes, and people get around quicker than they did before. And it's a much pleasanter environment. People live longer, healthier lives, and so forth. There are alternatives. We can do this.
You're right about how traffication and road ecology are a conservation blind spot among environmentalists. Could you tell us what you mean by that?
The reason I wrote this book really was because I was quite astonished by how many of my colleagues, I'm a professional conservation scientist, I was astonished by how little my colleagues and the conservation movement generally are aware of all these masses of different problems caused by motor traffic. Even though the scientific evidence showing that road traffic has immense impacts on the environment is just as comprehensive, just as good as that showing that climate change or agriculture intensification have huge problems as well. And it struck me that maybe that part of the reason is that no one's trying to pull all this together. No one's sort of trying to put it all these different strands, roadkill, fragmentation, air pollution, water pollution, all these other different things that we've been talking about, trying to pull them all together and say, look, if you put these all together and look at it as a whole, and then you compare it with climate change and you compare it with agriculture intensification, the evidence is just as strong, maybe even stronger. And I think that there's a positive here as well, because if we can embrace the possibility or the likelihood that some or much of our biodiversity loss is due to traffication, then it becomes a lot easier to fix. Because I think that of all the major environmental problems, traffication offers more solutions than any of the others. And what's more, if you implement those solutions, the impacts will be immediate.
Here in the US, there's a commercial for Subaru, which is kind of like the preferred car of people who are environmentally conscious. The commercial talks about national parks and how Subaru donates so much money to national parks. But it shows a car in the middle of a national park.
Well, there is a bit of a sort of problem here, isn't there? Because conservationists know very well that if people are going to feel moved to protect nature, they have to experience it. And one of the undoubted benefits of cars is that it allows people living in cities, which is, a very high proportion of all people, access to the countryside and allows them to see nature and therefore, potentially inspires them to protect it. And in fact, that's the very reason that cars and bicycles were invented in the first place. It was to allow city dwellers access to the countryside for recreational purposes. That, if you read what Henry Ford was writing about his aims, it was to give freedom to the countryside to city dwellers. It wasn't about, commuting or anything like that. It was a recreational thing. So there is this argument that, and this is maybe what Subaru were getting at in their advert, is that this mode of transport does allow you to get into areas that you wouldn't otherwise be able to get to. and, potentially feel moved to protect those areas as a result. The fact that your car is carrying thousands of seeds of potentially invasive plants and animals on it probably doesn't feature in the advert.
Let's talk about some solutions. What can be done to reduce the impact of traffication on like a large scale and like a human scale?
Experience shows that conservation actions only work if they meet three conditions. They have to be effective, they have to be affordable, and they have to be socially acceptable. And the thing that gives me some hope that we can reduce the worst impacts of traffication is there's loads of solutions that meet all three of those criteria. So in terms of roadkill, for example, there are loads of things that can be done that don't involve people stopping driving. Driving slower is definitely one of them, but there's now a whole science built around wildlife crossings. In fact, most of it coming from Canada and the USA in the 80s and 90s where these studies first started. And there are now fantastic designs that I always think of a road as being a kind of deep cut across the environment, a kind of deep wound. And these crossings as sutures, as stitches, stitching the wildlife communities on each side back together again. So the idea is that you have fences along the road to stop animals from wandering around and being killed by the roads, but you also have crossings. So these fences, they don't serve to turn animals back, they serve to funnel them towards crossings where animals can cross over the road or under the road in safety. And these have been shown to be fantastically effective. I mean, you can reduce roadkill to almost nothing, but they also address the problem of fragmentation as well, because they allow animals to move from side to side. And that's immensely important too. And there's a good financial reason for doing this, because hitting animals with cars is dangerous to us as well as to the animals. A lot of people get killed or injured in accidents striking animals, and it causes a huge amount of damage as well, valued in billions of dollars every year. So building roads helps animals, but it helps drivers too. So it's a kind of no-brainer, really. So at the same time, people are looking for tyre designs that don't sprinkle microplastics, biodegradable tyre designs, looking at how we can design roads such that road noise is minimised. We can use natural plantings along roads, which certain trees are better at absorbing traffic noise than others. There's a whole load of smart things we can do. We can drive greener by driving a lot smarter. And communications technology plays a big part as well. So there are all these visions now of having all cars communicating with each other and directing traffic flow so that there's no congestion. That would reduce journey times and reduce speeds as well. So there's a whole load of exciting ideas out there for how we can kind of minimise the impacts of road travel on wildlife and on ourselves that don't involve us giving up the car.
It strikes me that a lot of the things you mentioned involve kind of like tech fixes, not like behavioral changes.
Yeah, I know. It is interesting, isn't it? People say to me, oh, you're a Luddite, you don't like cars, you want to go back to horses and things. And I say, no, a detrafficated world is the exact opposite. It's a world that uses technology, smart technology, so much better than we do now. I mean, what does a car do? A car is a box of metal designed around a Victorian combustion chamber that burns the remains of Mesozoic sea life, which is what oil is. It's about as old-fashioned and cranky as you can get for an invention. And given that it's 150 years old, we haven't done very much really to improve on it. So a detrafficated world is a smart world. It's not a Luddite, technophobe, backward-looking world. It's quite the opposite.
I want to talk about some potential behavioral changes, like you mentioned speed, for example.
Pretty much all the problems caused by traffic to our health, to the environment and to wildlife increase exponentially with speed. The question then is how to encourage people to drive slower. Part of the answer is that if everyone drives slower, journey times would fall because congestion would fall, and congestion is the main contributor to journey times in most cases. I was really careful that my book didn't turn into a polemic against the car, which would be firstly hypocritical because I'm a driver myself, and secondly unproductive, because that isn't the way forward. I mean, it's a bit like Rachel Carson. I mean, with Silent Spring, the book didn't end with a call that these chemicals be banned, simply that their harm be recognised and their use be moderated, and that's kind of what I was aiming for, really.
Distillations is produced by the Science History Institute. Our executive producer is Mariel Carr. Our producer is Rigoberto Hernandez, and our associate producer is Sarah Kaplan. This episode was reported by Rigoberto Hernandez and mixed by Jonathan Pfeffer, who also composed the theme music. You can find all our podcasts as well as videos and articles at sciencehistory.org/stories. And you can follow the Science History Institute on Facebook, Twitter, and Instagram for news about our podcast and everything else going on in our free museum and library. For Distillations, I'm Alexis Pedrick. Thanks for listening.